So I'm going to walk you guys through how I approached the solutions to problem 16.1 and 16.2. So in 16.1, we're asked to fill in the details that lead from equation 16.11 to 16.14. So I have those equations written out here to start with. Then we can just start with equation 16.11 here. But then for the inverse f tensors, we're going to fill in equation 6.13 or 16.13 in both cases. So we're going to do the same thing here as well. Then we expand that out. We get this big long expression here. And then we can rearrange slightly and use our knowledge of the contraction rules with Kronecker deltas to simplify a little bit. So doing that in this step then yields the answer that we're looking for here. So all in all, a fairly simple problem. 16.2 is also relatively simple. So again, we're asked to fill in details that lead to equation 16.18. So we have that written out here. Looking back just a little bit, we find that 16.15 will be useful, as will equation 15.17. So starting off, all we're going to do is just take the derivative of equation 15.17. So in this case, all it is a product rule. You can write it out in index notation, but I was lazy, so I didn't. But that's what the derivative of f comes out to. Then we can use 16.15 and substitute our derivation or our derivative form of f into 16.15. So we get that here. Then going back to the original form before we took the derivative of 15.17, we can take the inverse of it. So we have an expression for this f right here, and then we can substitute that back into our equation for 16.15. So we get this guy, and from here on out, all it is just simplifying and multiplying through. So we do that, distribute this guy through to both of these terms. We'll get this step here, and then we just simplify a little bit. So u inverse times u is just going to be 1, so that drops out of our first term at least. And then the second term we can just rearrange a little bit. And then we get our final form of 16.18.